So in the earlier lecture, we couldn't finish this one. So let's look at it again. We argued that Vx, or magnitude of x component velocity, is really not the same for all molecules. But we could have sorted the molecules into groups having the same magnitude of Vx within each group, then added up the resulting contributions to the pressure. The net effect of all this is just to replace Vx squared in this equation by the average value of Vx squared, which we denote by Vx square average. Right, so we can relate Vx square average to the speeds of the molecules. The speed v of a molecule is related to the velocity components Vx, Vy, and Vz in this form, right? So we can write V square average is equal to Vx square average and Vy square average plus Vz square average, and this is average, right? And then we can argue that there's really no difference in our model between the x, y, and z directions, right? Molecular speeds are very fast in a typical gas, and so the effects of gravity are negligibly small. So from there it follows that Vx square average, Vy square average, and Vz square average must be all equal, right? And hence we can write V square average is equal to this plus this plus this, and they're equal, so we can say 3 times Vx square average, or we can say Vx square average is equal to 1/3. It goes to this side, just reshuffle, rewrite the equation in terms of Vx square average is 1/3 of V square average. And once we substitute this value here in P formula, then we can write P is equal to N over V mass and then 1/3 V square average, or rewrite the PV is equal to 1/3 N M V square average, right? So that kind of complements the earlier lecture. So we just got this relationship PV is 1/3 N M V square average, and now we know that total number of molecules times mass of each molecule is equal to mass of the sample or mass of the substance, and that is equal to we can rewrite N, capital N is nothing but number of molecules times the Avogadro number, right, and times the mass of each molecule, and then we can write it, this is equal to N times the molar mass. So N is number of moles and A times M, this is the total number of molecules in 1 mole, and so total number of molecules times mass, this is mass of 1 molecule, so total mass in 1 mole, that is called molar mass. So capital NM is interesting. The symbol capital NM is same as small n capital M. So I can rewrite this equation as PV is equal to 1/3 small m capital M and then same V square average, right? So we got kind of two relationships which we will use in next discussion. So let me box them for future references, right? Great.